Today we will be discussing important operation of arrays linear search. So we will see what is this linear search, what is the basic important operation we will be performing for this linear search, how this operation is performed, and we will write a simple line of code for this linear search. Okay, what is this linear search? This is very important operation of an array. Linear search. In this linear search, first we will go what is this searching. Searching. Searching is nothing but to technique to see the element is present in the list or not. This is known as searching. So when you have a searching technique, you have two different techniques in our data structures. One is linear search and one is binary search. Today, we will discuss what is linear search, then we will go with binary. What is linear search? Linear search technique, the element to be searched, key, that is whatever the element we are searching, that will be considered as a key or you can take it as data, is compared with each element of an array sequentially one after the other. And after comparing the element, for example, I'll take a simple example. I need to compare the element with each and every element. 1, 2, 3, 4, 5. I'll take key element as 4. I have to compare the item. That is, I have to compare each and every item. For example, I'll take 1. 1 I should compare with 4. No increment value of I. Then 2 is compared with 4. No increment. I'll come to here. 3 is compared with 4. No. Then come here. Now compare this. 4 is compared with 4. Yes, the two elements which I am comparing, they both are same. Once the both are same, the next thing is you have to write two important conditions. One condition is element is found and its position or its indexing. Second condition is element is not found. These are the two important conditions we consider in searching. Either it is binary search or linear search. For example, now key value is matched with one of the element. Now I have to print the statement element is found and it is in the location third indexing or it is in position 4. Have to print it on a screen. For example, I'll take key element as 6. Now look here, 1 will be compared with 6, 2 will be compared with 6, 3 will be compared with 6, 4 will be compared with 6, 5 will be compared with 6. Finally, none of the elements in an array are matching with the key element. So I have to print a statement, element is not found. So this is what the basic logic of a linear search. That is, first you have to compare each and every element, that is compare each and every item whichever you have with the key item. If the both after comparison, if the both elements are matching, you can write the element is found. If after comparison the element is not matching, you have to write element is not found. This is known as linear search, and keep this in your mind, this is very important. You can do it on an unordered, that is there is no ordering for an array. I can, for example, I have written 1 2 3 4 5. Even you can write, you can jumble the elements and you can do. Linear search can be done as an unsorted arrays also, or even it can be done on sorted arrays also. And very important disadvantage of this is this can be done only for a smaller size, and amount of time will be more compared to other searching. Linear search, the time is wasted compared to all other searching algorithms. So now we will see, this is the basic logic of linear search. Now we will see how do we proceed with this linear search. I will take one simple example and I will explain the basic code of this. Okay, I'll take 0, 1, 2, 3, 4, 5, 6 and 7. I'll enter the elements as 15. As I told you, this can be done even in an unsorted array. I am not doing it on a sorted array. I am doing it on an unsorted array. Then I am writing these elements. Okay. Now my key element is 42. I have to do this. My key element is 42. I have to search the items in this array. As you see this elements into an array, this is how we have done. We have done this with an, as I told you, with an arrays. We can insert an item into an array like using just a simple for statement. As I discussed this in one of the sessions, you can go through that session, array, insertion, and that is array, insertion operation, or even you can go with array initialization operation. So with the help of that simple program, we will be inserting an items into an array. That is, I can insert for I equals to 0, I less than n, I plus plus, scanf, percentage d, and a of I. This is what a simple logic to insert the value into an array. Now I have inserted the values into an array. I have inserted as many as I want. Now the key value, that is enter the printf. I can take an element, printf, enter the key element, enter the key element. This is one of the statement I can write, and then I can write it as a scanf percentage d and whatever the key element and key, I will take it as a key element and key. Okay, now I will take it as key is equals to 42. As I told you, once we have to start a linear search, we have to start from the beginning itself. You have to compare each and every element with the key element, go on comparing each and every element with the key element until the match is found. This is what a basic logic. So to do that, I have to take an I value. I keep on increment. I should increment like this. I should keep on going incrementing till you get a key element. So for that, I have to take for statement. For is must and should, because this, since I am using an array, I can do that. I can start from 0 because I'll start with indexing 0. For I equals to 0, I less than n, I can still go with less than n, then I plus plus. Okay, so this is what I have to start. Then I have to check the values. That is, for example, if this is a value, that is I is equals to 0, a of 0 is equals to key element. I have to check the condition, that is a of 0 is 15. 15 is matching with 42 or not. I should keep on doing this. This is the main logic. Take each and every elements of an array, then compare with the key element. That is what a logic. So to do that, what I do, I'll write an if statement. If a of I is equals to key element whichever you are given. You have given. Then if both are matching, printf element is found at indexing, or you can even write at position percentage d comma I. Wherever the indexing is there, that position it will take. Okay, this is what. If I compare, I have to write this. Now, for example, I keep on comparing, I'll not get my key element. What I have to do, I told you this, you have to write two statements. Else printf element is not found. Either you can write this here, or even you can close this and you can write it at the end. Now we will trace this program. For I equals to 0, I less than and I plus plus. N is, what is the n value? N is equals to 7. So now look here, I will trace this over here. I is equals to 0. 0 is less than 7, the condition is true. 0 is less than 7, the condition is true. So now we have 0. 0 is equals to what? 15. 15 is equals to 42? No. So this statement, if a of I is equals to key, no, false. If it is true, you have to come here. Now again, go back to the for statement. Now we increment the value of I by 1. Now n I is equals to 1. So 1. 1 is less than 7. Yes, the condition is true. A of 1 is equals to key. So what is if? A of 1. This condition you have to check. So now if A of 1 is 5. 5 is equals to 42? No, false. Again, increment the value of I by 1. Keep on doing that. I by 1. Now a of 3 is equals to 42. No, false. Now again, this is if condition. Again, go back, increment the value of I by 1. A of 4. Then is equals to 42. False. Then a of 5. A of 5 is equals to 42. What is a of 5? 42. 42 is equals to 42. This is what I land here. If a of I is equals to 42. Now a of I is equals to key element. Now my data is found. So you just print this statement and you can come out of the screen. So now if this statement is completed, I'll print this element. Element is found. Now 42 is found. 42 is found on the screen. 42 is found and I have to come back. So now to come back, what is important? I need to write break. This is very, very important. Write break here, come out of the screen. If, for example, I'll give some element k is equals to key is equals to 80 now. Keep on doing this same thing, like whatever I have, the same logic is there. If a of I is equals to 80, keep on comparing with each and every element. 15 is compared with 80, no. 5 is compared with 80, no. 20, no. 35, no. 2, no. Till the end it will come. And it will stop near the condition now. Then I will become 7. I is equals to, now I will become 8. 8 is less than 7. The condition will become false. Even this condition will fail. This condition will also fail. Finally, somewhere these two conditions will fail. Now you can write this as else print element is not found and you can come out of the screen. This is what linear search we are doing. You don't want this else part, you can skip this else part. You can just write print element is found. You can break this and you can, this is what a simple logic I am explaining. You have to alter the program whichever you are writing. So break and come out of the screen. This is what linear search technique, that is searching each and every element. Whatever you take that element with the key element, you have to compare each and every element once. Take this first element, compare with this key. Take the second element, compare with this key. Keep on incrementing and once you found, you can write it as a element is present. Then if, as I told you, I can write else and I can just write. I don't want to do that. Even you can write if statement. If everything is complete, that is, for example, I'll take key element is equals to 60. Nothing is done. Here, this will become false. Even this will become false. Finally, you can write a statement if I is equals to n. Finally, I'm reaching n. I is equals to n. That is 7 is equals to 7. If finally I'll reach an ending position where both are equal, I can write printf statement element not found. Even no need to go to 8. You can stop here itself. Element not found, break, then come out of the screen. These are the two important possibilities, two important things you can do. So this is known as linear search. This is the basic important technique of linear search. This is very, very important. Logic of linear search. Keep on comparing each and every item with a key element. Somewhere it is found, you can write element is found and you can write the position of that element. Based on this, you have to write a program. Thank you.